Hello, everyone. Thank you for joining us today. My name is Emily Kuda. I'm Percona's Digital Marketing Manager here. We'll get started in just a moment. First, I just want to conduct a little bit of housekeeping. Can you raise your hand located in the GoToWebinar control panel to let me know that you can hear me? Great. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible. Those that aren't addressed will be answered in a follow-up blog entry on Percona's database performance blog. In addition, a copy of the recording and the slides will be sent to everyone within 48 hours or less. So with that said, I'd like to thank you for attending today's webinar, Supercharge Your Analytics with ClickHouse, presented by Percona's CTO, Vadim Tishenko, and Elanti's co-founder, Alexander Zaitsev. With that said, I'll turn the floor over to Vadim.
Hi, Emily. Do you hear me?
I do.
And do you see my screen?
Yes.
Okay, good morning from California to everybody, and thank you for joining our webinar. Today, me and Alexander, we're going to speak about ClickHouse. And let me just start with this. Okay. Seems. Okay, let me start with a quick overview how we see current state of analytic database landscape. And if you look on available solution on analytical databases, we divide them in two parts. First part is a commercial solution. They are really fast and feature rich and very capable. There's such solution like Vertica, Redshift, Teradata, and so on. The problem with those solutions is that the cost scales along with your data. And the more data you have, the more demand you have on these systems. They become very expensive and very fast. And on the other side of this line, there are open source solutions available for analytical workloads. To name few, there is MariaDB column store, formerly known as InfiniDB. There is InfoBright, which lately was not very active. There is a Green Plum, originally started as a commercial. And there is a variety of tools and databases on Hadoop ecosystem, and a more recent analytical database, Apache Spark. This solution are free, but I would say some of them not very convenient to use, and some of them kind of slow. For example, it's very hard to claim Hadoop as a real-time analytical solution. So that is why we're looking on ClickHouse. ClickHouse, I think, fits into a very nice sweet spot between those two, and the ClickHouse claims to be both fast and free. And it was open source really only a year ago, but it gained some popularity very fast. And I would say it's also a very performing database with the numbers I will show you later in my presentation. So let's take a real quick overlook into ClickHouse story. So it was developed by Yandex company. Yandex, if you don't know, it's a very popular Russian search engine. In that part of the world, it's much more popular for search than Google. And it also provides a service similar to Google Analytics. It is Yandex Metrica, and they handle incredible amount of load. they handle 30 billions of events daily. So they had needed to develop an interactive real-time reporting on multiple petabytes scale. So, and there was no commercial and no open source solution available to develop to handle their workload at this scale. That's why they started to look into developing in-house technology, which they named ClickHouse. And they saying they had with this kind of scale, they had no choice but make it fast. But jokes aside, they had very demanding initial requirements. They had to perform data processing in real time, to be capable of storing petabytes scale of data. They also were looking to implement it in very fault tolerant way. Even on the data center scales, the solution had to be very highly available and with a minimal downtime. And to be interesting for developers, they look to implement a very flexible query language. So and so how they're trying to achieve speed and performance. ClickHouse deploys several strategies. First one is vectorized processing. About this on next slide. They also provide a massively parallel processing. I also will go in details. They are shared nothing on the multiple nodes. And the ClickHouse is a column store system with late materializations, which allows them to achieve very good data compression. They provide column locality, and there are practically no random reads. All massive data handling done in the sequential reads. And if you want to look in more technical details on this, you can look up on a presentation, which unfortunately available only in Russian, but you can look into diagrams and schemes. So vectorized first technique, vectorized processing. Basically, they're looking to deploy strategies available for a modern CPU to handle data in arrays that allows to perform to deploy very serious optimization and performance improvements to use modern CPU instructions and out for the execution and pipelining. There are papers which claim that deploying vectorized execution can improve data-intensive queries by a factor of 50. And the second strategy is column-oriented, in contrast with traditional databases, which are row-oriented, like MySQL, InnoDB, and Postgres, and basically all OTP databases. Analytical databases very often are column-oriented. This allows to read data only you need, and allows to work with the data which you need. So let's take a look on efficient execution. For example, we took this query. This query performs filtering on where condition. You can see there is a filtering by two fields. There is also aggregation by group by, and also sorting for by count. So this query will be executed very efficiently by deploying strategies I mentioned first, this vectorized processing data handled pretty much in array and batches. ClickHouse will read only columns you need. In this case, only counter, ID, referer, and date. And if your table has more columns, ClickHouse will not touch it. There's also a great compression strategy that when data is read, it's read in a compression way. And also, if you deploy proper index or in ClickHouse terms, primary key, for example, for this query, proper index could be counter ID and date, that ClickHouse will be able to discard unneeded blocks very fast when executing this query. And let's take a look on massive parallel processing. I took a little experiment. I used my server with multiple CPU cores and multiple CPU threads, and I took Apache log from a real website, one of Percona websites, and this log contains 1.5 billion records. So I wanted to take a look on the several queries. First query, which in my opinion very suited for parallel execution. This query is more CPU intensive, and because it works on a regular expression on one field. So most time spent in this extract function. And I took a server available. This server based on Intel Xeon CPU with 28 CPU cores and with 56 CPU threads. And let's take a look on the query execution time. When I allow only one thread available for ClickHouse query execution, or query execution time is 823 seconds, which corresponds roughly to 1.9 million records per second in processing time. But when we allow all 56 threads, then query execution time drops to 23.5 seconds, which corresponds to over 66 million records per second in handling. So basically, we're looking for speed up about 35 times on multiple threads. And if we draw a graph of speed up to CPU threads, we can see a very nice linear increase up to first to amount of CPU cores, and then when increase is not so significant when we start using CPU threads. So apparently Intel CPU threads and not such efficient for parallel execution as if we only use CPU cores. But not all queries created equal. So if we take a more complex query, which I think is less suitable for parallel execution, there is a serialization to build a temporary table for an internal subquery. So for this query, if you measure again one thread against all 56 threads, the speed up we're looking for is only 6.4 times. And the graph on speed up against CPU threads looks like this one. And again, this all depends on your query. If a query is less suitable for parallel execution, you might expect less parallelization and a smaller speed up on multiple CPU threads. And more details about this experiment you can see in our Percona blog post. So what happens if a single server is not enough? If you're looking to increase performance even more, in this case, ClickHouse provide a variety of ways to distribute your data. So you can you can deploy ClickHouse on multiple nodes. In this case which I show is this, you can deploy on 3 nodes, and then when you execute query against a distributed table, there is efficient execution that query executed in parallel on each individual server, and then results being aggregated on a central node. So ClickHouse is able to distribute in parallel a load on multiple servers. And from another experiment, if you take a look on this query and publicly available data set, this is a New York taxi data set, which you can find in Google. This dataset contains 1.3 billion rows, and for experiment there is this query again with aggregation and average function, and in this experiment from 1 to 3 to 140 servers, we can see how we can improve query execution time from 1.2 seconds to a little bit under a half second with 3 servers, and even further with 140 servers. Obviously, that's I don't think 140 servers is needed for this query, but we can see how we can improve query response time by distributing load across multiple nodes. With performance, ClickHouse also provides a great level of reliability, because this was one of requirements for Yandex, and the ClickHouse provides numbers of replicas and complex replication topologies. It provides a multi-master replication and also across data center replications. And but also it is asynchronous. This should be very similar for MySQL users, which means actually that you may have some delayed replicas and possible stale data reads. So you should take this into account when you work with ClickHouse replication. So I also wanted to show you some more benchmarks done by Percona, by Altinity, and by Yandex itself. So this is to prove that ClickHouse performance was validated by different companies. It's not only Yandex. Not only we need to take Yandex words on ClickHouse performance. First benchmark is done by Percona consultant Alex Rubin. He took Wikipedia page counts datasets. It is also publicly available, and from year 2008, it actually contains 26 billion rows. Again, if you take a look back, we operate on billion rows levels. It's a kind of a huge amount of data, and we can see that we can handle queries on this amount of data in just seconds time. And more details about this benchmark and the experiment available on our blog post. But when we take a look on 3 different queries, and they compare with Spark and MariaDB column store, you can see that ClickHouse outperforms this system by serious numbers. And again, for kind of complex aggregated queries over 26 billion rows, it took only 16 seconds for ClickHouse to return aggregation by month. We also Alkinity also took experiment on cloud deployments and compared ClickHouse with popular cloud analytical database Redshift, and this is based on a New York taxi dataset, which I already mentioned, and we took 5 different queries, and the query example you can see there again this aggregation and sorting, and again it is over 1 billion rows. So we compared the ClickHouse 1 instance with Redshift 1 and even three instances on somewhat what we think equal hardware. And their results, we executed 5 different queries and measured query response time in seconds. Obviously, the faster is where it takes less seconds to execute. And we can see that only in one case, ClickHouse becomes slower, but we also propose ways to deal with this. But in other cases, ClickHouse, you can see ClickHouse is faster than Redshift 1 nodes, and in even some cases, ClickHouse is even faster than Redshift 3 nodes. So ClickHouse is also very capable to perform in cloud deployments. And there are some more benchmarks comparing even with the commercial databases like Vertica and others, and are available on Yandex website. Obviously, you can say that Yandex is biased, but then I think you can verify these numbers by yourself. So we know which cases ClickHouse is suitable to use. Basically, I see ClickHouse is very capable when you need to handle kind of log or event-based data sets, or some kind of stream of data which are time-stamped or well structured. Basically, we're looking for all kind of monitoring or kind of sensor for Internet of Things data sets, telecom logs, and web or application analytics. And there we should mention some cases when ClickHouse is not very suitable. Obviously, this is not online transactional processing database, so you should not even try to handle online transactions with ClickHouse. It is not a key value store and not a document store. If you will try to perform a lot of point key lookups, ClickHouse will not perform very well on this, comparing even say with MySQL. Again, ClickHouse is designed to handle a billion of rows cases, not point lookups. And at this moment, you cannot perform update and deletes on ClickHouse dataset, and it basically supports only insert data and perform analytical queries against the dataset. And there are obviously some limitation which I believe we should mention. That ClickHouse provide SQL kind of query language, which you saw on my previous slides. Queries which I proposed were kind of or properly SQL queries, but the language by itself, it has some limitation. and as a consequence, it might not work with all variety of business intelligence tools available on market. In my some tools might not support SQL dialect of ClickHouse, so it might require some adjustments. Again, there is no delete updates statements available, but there are some workarounds we can propose, like external dictionaries. Alexander, I believe, will mention dictionaries in his part, and there is also mutable table types. ClickHouse is still very young, as I said, it is only 1 year old. So there is no variety of tools to manage and monitor ClickHouse. The ecosystem is still very young, and I would say we're very passionate. With even tools are limited right now, we see a lot of development and a lot of contributions around ClickHouse ecosystem. So there is to mention, there is already graphical interface tool, Tabix IO available, Apache Superset enterprise ready business intelligence web application provides support for ClickHouse. There is Grafana integration for ClickHouse, and there is ODBC and the GDBC drivers available, so you can use either from your Java or Windows application and work with ClickHouse data. And this is just to show available graphical interface tool Tabix IO, where you can actually execute and see results and graphic representation. And again, what's interesting in this one, you can see that handling aggregation per month over 1.5 billion of records was done just in a half of second. That's kind of cool. So who you might ask, who is using ClickHouse beside Yandex? And there's several companies which already publicly published their work with ClickHouse. To mention a few, there is Carto. They shared their experience with handling geographical data set with ClickHouse. We in Percona, we're looking to integrate ClickHouse as part of our monitoring and management software to handle log of queries for our query analytics part. And also big user of ClickHouse is Cloudflare. They shared their experience in their blog post, but also on yesterday meetup, they provided a little bit more numbers. So they basically use Cloudflare on 33 nodes, and they handle petabyte scale data set, and they handle over 8 million searches per second into ClickHouse. And more on Cloudflare experience you can see in presentation which available from San Francisco MySQL meetup website. And if you want to play with ClickHouse and you don't want to install it, even it's very easy. We partnered with Kodiak Data. This Kodiak Data provides cloud for big data, and we deployed ClickHouse demo, which you can go and try to play with ClickHouse deployed on Kodiak Data by yourself. And to finalize my part of presentation, so I believe you can easily go and try ClickHouse for your analytical big data case. If you need more information about ClickHouse as software, it's available on ClickHouse Yandex website, and you always can reach me through my email or lim@percona.com, or contact me through Twitter. And I think on this I end my part, and I invite Alexander to share his experience with ClickHouse. Alexander, are you ready?
Okay, thank you very much, Vadim, for the great ClickHouse introduction, and we'll continue. Let me introduce myself. I am not so famous as Vadim for Percona folks. I'm graduated from Moscow State University in 1999 and working as a software engineer a little bit before that. And since early 2000, I started to work on distributed systems and later on focused on high performance analytics. This is my current main area of expertise and interest. I am director of engineering in LiveStreet, responsible for analytics infrastructure, and we co-founded Altinity earlier this year to provide ClickHouse services. So what we'll be talking about, I'll talk about a LiveStreet ClickHouse implementation experience, how we implemented and deployed the second largest ClickHouse installation so far after Yandex. And we'll talk briefly about MySQL and ClickHouse as well, how they can produce together their interesting results. So what is LiveStreet, the company I'm working on? It's a tech company, pretty old. It has been established in 2005 or 6. It's an exchange company with its own ad server, RTB services, DMP, and so on. As such, we have to process about 10 billion events per day, which are bit requests, impressions, and so on. We are stored in 10 plus fact tables and aggregates. Several hundred dimensions, 500 is probably quite low number. It could be higher indeed. And 100 or more metrics. I don't know exact counts, but they're pretty huge. We have internal and external users, and we have a lot of algos and machine learning algorithms and different kinds of robust daemons and so on, and they're all using the same data. Other 10 years, we tried and used different solutions, different available technologies, starting from MySQL, then moving to Oracle, to Vertica. We evaluated and made pilot for many other databases. And last year, ClickHouse has been introduced to open source community, and we decided to try it out. So some flashback, what ClickHouse was in August 2016. It was still 1-2 months in open source, very, very new technology for the community. It was internal Yandex product, and there were no other installations known to the moment. It had no support, no roadmap, communicated plans, and so on. If you go to GitHub repository, you can see that there are only 3 official developers or contributors at that time. It had a number of visible limitations, and as you can guess, if there are visible limitations, there could be invisible as well. And we were concerned about stories of other open source databases that were released open source because the company developed the technology is going to go out of business. This is not the case with Yandex, certainly. So the initial reaction when we had an idea that we were going to implement the huge production system using this technology was like this. It's kind of crazy. And this is not because the technology is new, but because it's pretty limited comparing to traditional databases. It doesn't have transactions, constraints, consistency and referential integrity, update and delete functionality, nulls. That was true for 1 year ago, but not true anymore. There are nulls already. It couldn't store time in milliseconds. It didn't have implicit time conversions, which is very inconvenient. And it doesn't have full SQL support, and partitioning is also pretty limited. So a lot of limitations if you come from database world, especially from MySQL or Postgres, and this is pretty frustrating to developers. So the developer reaction was also very illustrative. And initially we had a lot of tensions when we started this project. But finally we tried and succeeded, and this is our success story. So what we have had to do and what we learned. So mainly when you want to migrate from some known technology to something new, the problem is the same. The basic things and basic habits, it doesn't work in a new environment. So when we started ClickHouse migration, we faced with several challenges. First, we had to design efficient schema that uses ClickHouse bests and works around limitations that are many. Also, we had to design sharding and duplication scheme which is necessary for high performance and also fault tolerance and availability. Data ingestion or data load is also a kind of interesting project because you have to handle huge amounts of data with low latency, and interruptions of load are not allowed due to nature of the web traffic. And the last but not least, we had to migrate client interfaces, and that was a problem because SQL dialect is not standard. So typically, when you work with analytic applications, you work with star schema. So it looks like the main table and probably several dimension tables, where the main table, which is usually called fact table, is huge and might contain millions or billions of records with different characteristics of some event or transaction or whatever. Dimensions, they may be pretty small to be stored in a fact table or stored in the separate tables. And it's called star because if you look at the main table and several leaf tables, it sometimes resembles a star. Metrics are different functions against on top of your fact table, for example, some sum of revenue or count of operations and so on. And projections we probably don't want to discuss here, but these are projections of the fact table to a smaller number of dimensions with possible aggregation. So there are two approaches to the schema design. First is denormalized schema, and second is normalized. In denormalized, all dimensions are stored in a fact table, and this is very easy to implement. You have just one table. The queries are very simple. You don't need any joins. However, there are drawbacks as well. No data changes are possible, and the storage is sub-efficient, and queries are sub-efficient as well sometimes. Normalized schema is sometimes better, but it's more difficult to maintain because there are many tables involved. The queries are always also more complex due to necessity of joins. However, dimensions can be easily updated because they are stored in the small tables, and you can change them without affecting the main table. The storage is also more efficient because in the fact table you usually store only dimension keys, and all the extended data, which are usually strings, are stored in separate tables of much smaller size. And because of that, queries are also more efficient. It's much faster to filter by integer columns, which are keys, than by strings. So traditionally, data warehouses follow normalized schema approach and use joins in SQL databases. However, we faced with this problem here. ClickHouse has pretty limited support of joins, and it's still true till the moment. It has only one level of joins, and you have to cascade with subselect for multiple joins. There are a few other things with that, and also dimension tables in ClickHouse are not updatable. That makes normalized schema with joins sometimes not very easy to implement. But there is a good news as well. ClickHouse provides its own approach to dimensions, which is called dictionaries. Dictionary can be considered as a lookup service with key value mapping. It supports multiple external sources, so sources of the dictionary could be files, databases, etc., and easily refreshable. That is the most important. Here's the example that says more than any words. There is a query that uses join in ClickHouse SQL dialect, and the same query rewritten using dictionary and dictionary access function. As you see, this dict get string function. It accesses the dictionary with country name column in this dictionary and uses geo key as a key. So instead of query with join, you have a query without join. This is all we wanted to do. So here's an example of dictionary configurations. Unfortunately, to the moment, dictionaries are configured externally using configuration files in XML. However, the ClickHouse team is working on moving dictionaries to the schema, so they could be created using DDL. So the dictionary definition consists of the source parameters, lifetime, layout, and the structure, which describes keys and attributes of the dictionary. So it's very natural to have a dictionary sourced from a MySQL database, and this is what we did as well. In addition to MySQL table, there could be sources like file, ClickHouse table, ODBC data source, executable script, or even HTTP service, which could be useful for some use cases. And it's possible to update dictionaries values, and by default, it's updated by timer using some predefined period. For MySQL, MySum tables, it could be done automatically because in MySum you always know the last modification table, last modification time. Recently, probably a couple of months ago, Yandex team added the new method which uses invalidate query parameter, and it allows you to store the version or timestamp of the last dictionary update in ClickHouse, and ClickHouse checks the query hitting the source database to check if this value changed or not, and if there is a change, then it refreshes the dictionary. Also, it's possible to touch the config file on the file system, and this is what we had to implement without invalidate query. And if config file is touched, then ClickHouse reloads the dictionary. Some warning here, ClickHouse keeps open database connection for every dictionary from every ClickHouse node. So if you have n dictionaries and m nodes, you can have plenty of database connections. It's usually not a problem unless all dictionaries should be updated at once. That can eventually kill the database, the source database. There are certainly some restrictions on dictionary. And here are a few of them. The keys for dictionaries should be only assigned in 64. This is true for flat and some other layouts. I don't want to discuss it here, but it's possible to use keys of different types, but it's not so efficient and a little bit more complex. There were no on-demand update, and it has been added just a week ago or this week. Every cluster node has its own copy of the configuration file that may result in inconsistency of dictionary configuration. So you need to keep an eye on that. And so far, it's XML configuration that is not very convenient. It's a part of the schema, and ideally should be defined as in DDL. But in a nutshell, this is the true silver bullet for the star schema implementation in ClickHouse, and this is what we did and spent a lot of time on that. Now let's move and talk a little bit about tables. ClickHouse tables are very flexible and actually the key to the ClickHouse performance. There are multiple engines. Tables can be sharded across multiple nodes. There is a distribution mechanism and access to distributed tables, and tables can be replicated for high availability. We'll talk briefly about that. ClickHouse supports a lot of engines, probably more than a typical MySQL installation does. Some engines are completely in memory and some on disk, and some engines don't represent the actual table, but more like an interface, like, for example, like distributed or dictionary engines. And there are special purpose tables to represent views and materialized views. In memory, engines are used for temporary tables or buffers mostly, and disk-based tables are used for permanent data, and the most important here is merge tree engine. So what does merge and why is merge? It's called merge because of the structure of the data. ClickHouse is very fast on inserts because when the data is inserted, it only the inserted block is the only thing that needs to be sorted and written to the disk. So no other nothing else is happening during the insertion. But later on, there is a special merge process that takes partially sorted disks, partially sorted blocks at the disk and merges them all together in order to create the most efficient storage structure. The blocks of the table on disk are sorted using primary key, and primary key is often a confusing name for that because it doesn't guarantee any uniqueness, unlike the usual primary key. It only guarantees the sort order. Also, merge tree supports date partitioning, and to the moment it's only monthly, but Yannick's team is working on make them more flexible. And merge tree is the key gate to the efficient query performance. So if a merge tree table is properly designed for the particular workload, it can query data extremely fast, as you could see in benchmark presented by Vadim a while ago. So now let's talk a little bit about data load. ClickHouse supports multiple formats, including CSV, TSV, JSONs, native binary, and some others. It has error handling mechanism, and skipping proper certain error counts is possible. It's possible also to perform simple transformation during data load, but we don't use it in favor of temp table as a some staging place, and then move the data to a temporary table, to the permanent table. It's possible to load data locally to the particular server, and this is the better approach, or load data directly to the distributed table, and in this case, ClickHouse distributes data across different servers on its own using some hash function. ClickHouse doesn't support any duplication by itself, but if table is replicated, then Zookeeper, which is responsible for replication synchronization, keeps some checksums that are useful for dedub. So it's possible to dedub for replicated tables. Also, it's worth mentioning that ClickHouse is has very good functionality of materialized views. Materialized view is just a table, so it has all the properties of the table. But in addition to being a table, as being a table, can be inserted directly. But usually, it's updated by ClickHouse server by itself when the data is inserted to the main table. And this update is synchronous, which makes it very convenient for certain types of aggregations. And for aggregation purposes, ClickHouse provides the sum and merge tree engine, which just sums all non-primary key columns. And the combination of sum and merge tree and materialized view is the way to go with aggregation in ClickHouse. It's very convenient and very reliable. So here's a data load diagram, which represents a different way to load data in ClickHouse. You can see log files which go to temporary tables first when they go to fact tables, and this is all local to the server, so it's shard tables. ClickHouse updates materialized views in sum and merge tree tables. Another way is to use the real-time data, for example, from some producers that write data directly. And because ClickHouse likes huge inserts, and in order to do that, buffer tables can be used. So when the data inserted to the buffer table, it is collected in memory by ClickHouse itself, and then flushed when a certain thresholds and conditions are met. As I mentioned, this is all local to one node. So if you have multiple nodes, you better to load. You have the same data loading scheme on every node in order to have the data properly distributed. A few words about updates and deletes. As you know, ClickHouse doesn't support updates and deletes, but dictionaries are updatable. There are also two special purpose engines which are replacing and collapsing merge trees, and they can eventually update data. So it's possible to insert two different records in the replacing merge tree table with the same primary key, and the later one replaces the previous one. It doesn't happen instantly. It happens when merge process takes control, but it's possible to take the last version using select final statement. And also partitions help with data deletion if you have a lot of data. A few words about sharding and replication. Sharding and distribution, this is the key to performance, to scalability. So if you have a lot of data and you need more performance, just distribute data to multiple shards. So we always distribute fact tables and normalized views are the multiple shards. However, the dimension tables and dictionaries, they need to be replicated to every node for the efficient queries, because joins are local and filters are local to the node. Replication, in turn, it stands for reliability, and it makes sense to have 2 or better 3 replicas per shard for the quick recovery. It's possible to have cross data center replication as well, but beware of some zookeeper issues with that. ClickHouse SQL is not standard. ClickHouse supports basic SQL syntax, but the main difference is non-standard join implementation. It's on the one level. It's possible to select to join any versus all matching rows from the right table. This is pretty unique for ClickHouse, and this is explained by non-uniqueness of primary key. And the join syntax supports only using, so that columns needs to be named identically on both sides. This is also pretty inconvenient and requires to use subselects in some cases. ClickHouse supports aliasing everywhere, not just table aliases or column aliases, and it has a very well developed array and nested data types, and that supports lambda expressions and array joins, so it's possible to transpose array to the column and vice versa, and do many array-based operations very efficiently. It has approximate queries, for example, approximate uniques and sample queries, and some basic analytical function supports, for example, topics. So let's revisit our main challenges. We had to design efficient schema, sharding replication, reliable data ingestion, and client interfaces, and it all took a while. So we started the project in August 2016 as a proof of concept, and in October 2016 we already had first test runs of the data loaded to ClickHouse system. In December we rolled out the pre-production cluster, which consisted of 24 servers, so 12 servers and 2 replicas of each. But we're already able to load our production level data, which is 10 to 50 billion events per day, which is something like 20 terabytes of data daily loaded to the system. By March, we migrated client API and started migration. We had a lot of different client types and huge query load, so it took a while to migrate all of them one by one. And during migration, we realized that we need to extend the capacity. So we extended to 60 servers. So 20 servers, 3 replicas each. And in June, we completed the migration successfully, and so far operate production ClickHouse system with 2 petabytes of data. So right now, comparing to what we had a year ago, the ClickHouse is more than a year in open source. It has 100 plus product installs worldwide. It has public changelogs, roadmap plans, very active community, a lot of contributors. So you can find blogs and case studies. And a lot of features were added by community request by Yandex team. And if you need support, there is support by Altinity. Overall, the situation is much, much better if you start ClickHouse project today than it was when we started. So just try and you will find the success. So this is all about LiveStreet, and a few words about ClickHouse and MySQL. MySQL is a very good database, but it's known for its weakness for analytical queries. And there are special purpose engines in MySQL, such as TokuDB and InfiniDB, that somewhat help, but it's not enough. And as we saw in this webinar, ClickHouse is best in analytics, so how to combine them? Is it possible? So imagine if we had MySQL flexibility at ClickHouse speed. So far it's only dreams, but still we can get pretty close to that. Here is an example of how ClickHouse and MySQL can be used together. There is a proxy SQL open source middleware, which is pretty known. It has been recently extended by ClickHouse protocol support. So it's possible to access ClickHouse via proxy SQL. From the other side, there are a number of implementations of MySQL binlog processing that write data to the different database, and it's not a problem to make the same for ClickHouse. We're currently working on that. Altogether combined, you can get a system when the data is going to MySQL as it was before. Using binlog consumer, it's then propagated to ClickHouse and accessed using the same client software using proxy SQL, but with the ClickHouse speed. And this is not a dream. It's pretty possible to do in a couple of months probably. Another thing to mention that ClickHouse can be used instead of MySQL in the applications when people usually try MySQL first. Weblog analytics, all kinds of ClickHouse is best in that. Monitoring data collection and analysis, ClickHouse is very good in that, and there are many examples already, including Percona, Percona PMM, Infinidata, Infinimetrics, and other products. So in a nutshell, any time series application can be used efficiently with ClickHouse, where people usually start with MySQL. So try it, and you will not be disappointed. This is all with my part. So thank you very much for your attention, and I can answer questions if any.
Thank you so much for that, Alexander. At this time, we'll go ahead and answer any questions that you have. Go ahead and enter those into the GoToWebinar control panel. So our first question is, why isn't it possible to update records in ClickHouse? Is it so hard to implement?
This is a traditional limitation of many column store databases. In particular, when Vertica started, they didn't have updates and deletes for a long time. And the difficulty here comes from the nature of column store. The data is stored in columns, and column is compressed. And usually updates and deletes go to the row based. So in order to update one row or delete one row, column store database have to load all columns, and usually columns are stored in huge blocks. and find the data to update here, rebuild the column, and store it back to disk. It's very, very complex and not efficient operation. That's why usually it's not implemented at the first time. However, it's possible to implement, and we know how Vertica did that, and I know that ClickHouse team is working on updates and delete implementation, targeting to second quarter of 2018 currently. Next question.
Thank you. Our next question is, can ClickHouse be useful for analyzing not billions, but up to 10 to 30 million records? Will it be faster than like MySQL or Postgres SQL?
Absolutely. If you have 10 million or 100 million of records, you can use ClickHouse as a single server. It is very easy to set up and very easy to load the data, and it will give you 100 or 100 to 300 times performance increase over traditional MySQL. And the performance difference here comes from the multiple factors. First, ClickHouse is able to analyze all CPU cores, and this is what Vadim demonstrated by his tests as well. And second, due to data compression, the data in column store is very efficiently compressed, and it's much faster to read from the disk and process.
Thank you. Our next question is it possible to use together mutable and immutable ClickHouse engines in one query?
Yes, there are now limitations of the mix of different types of engines. So no limitations, you can use them, yes.
Thank you. Our next question is, does ClickHouse support stored procedures?
No, ClickHouse doesn't support stored procedures, and it's not in the newest plan of the ClickHouse development team, to the best of my knowledge. And the reason is that it's pretty hard to implement, given the fact that ClickHouse is developed in C++ with efficiency in mind. So the short answer is no, it doesn't support. If you want to discuss that, we can talk about that a little bit more.
Thank you. And our last and final question is, I have a MySQL inserting data at 50,000 insert per minute. How can I export or pass data to ClickHouse to achieve the faster grouping and analysis?
So if you have the working application with 50,000 inserts per second, the best way to do it with ClickHouse is to insert them into buffer table in ClickHouse, or use some sort of buffer mechanism outside of ClickHouse, and then just insert the ClickHouse. It's not possible to do it without any code changes, right? So you have to make certain changes in order to move from MySQL to ClickHouse. But once you do it, you can have the blazingly fast ClickHouse performance, which is 100 to 300 times faster than single MySQL instance on the same hardware. So if you want any help with that, you can email me directly and I can explain, or you can look into recent Vadim Tkachenko article in Percona and Alternative blogs, where he has an example of inserting Apache logs into ClickHouse. So there's an example of insert syntax. So just try it, and that's it. And moving forward, as I mentioned two slides ago, we are working on BinLog consumer from MySQL to ClickHouse. So eventually, much less changes will be needed to an application. So you will be keep and inserting data to the same MySQL table, or probably different MySQL table, but connected to ClickHouse using this more consumer functionality. At the moment, you have to change your application and write that data to ClickHouse instead of MySQL in order to get reports from ClickHouse.
Thank you so much for that. So we are at the top of the hour. Thank you so much for joining us today. And huge thanks to you, Alexander and Vadim, for presenting today. And we hope to see you on future webinars. Thank you.
Thank you everybody. Thank you, Emily. Have a good day. Bye-bye.